Alright, so here I have a sculpt in ZBrush, and I'm just going to, in this demo, go through the whole process of taking a Dynamesh sculpt out of ZBrush. I'm going to do a quick retopologizing using the z-remesher, and then exporting to Maya, setting up displacement maps and normal maps. So here I'm just going to go and export an OBJ. So just straight from the Dynamesh, just go and export as an OBJ. So I pre-recorded this and I'm commenting afterwards, so if you see a slight mismatch sometimes, that's because I'm narrating after the fact. So here we go. Setting up a Maya project, that becomes obviously very important because you're going to have a lot of files associated with the project, especially if you want to do multi-UDIM UV layouts. Then you're going to have, of course, multiple image maps per channel, so multiple color maps, multiple displacement maps. But in this course, we're just doing normal maps or displacement maps. And you can choose which one you want to do. So normal maps are obviously more for games, and displacement maps would be more for visual effects rendering. So here we see I'm still getting that OBJ exported and just placed where I want it to be. You see I just made just a few hot on the shelf there, just made a few buttons, delete history, freeze transformations. One is for actually open the hypershade, and then I just made a button for import. And I've also removed all the user interface elements I don't need. So sometimes it's worth the while setting up your UI a little bit. I might save you some time and you have a little bit more space to work on. Okay, so here I have the OBJ in Maya, and right now I'm making a polygonal cube at 25 centimeter times 25, and that's just to measure the size of the head. So when I'm sculpting in ZBrush, it doesn't give me a real good measure. So this is something I actually would always do if I'm taking a Dynamesh and turning it into a production mesh, because scale is still really important. And even just for a render, the scale of the object will actually influence the light. So if you want to have light falling off the character naturally and have a correct fall off, you need to be considerate about the scale. So I just scaled it up to match. So this object is, like I said, it's just straight out from the Dynamesh, and we're looking at the same thing here in Maya. But I'm just rescaling it, freeze the transformations, delete history, and then I'm going to go ahead and export this rescale version. So that's the resize one is the one I'm going to use as a basis for retopologizing and also making UVs for it. So just initializing ZBrush. Just go to import, and I'll find that OBJ. Just put that in the data directory of the Maya project. Turning on perspective, switching to basic material. So here we go. Technically, we're looking at exactly the same thing. It's just now in the right size. And I'm already here now engaging the z-remesher guide curves, just diving in there, and I'm going to try to retopologize this using the z-remesher. So yeah, radial topology around the eyes and radial topology around the mouth, and I'm also just indicating that nasal labial fold. So you'll see me, I'll have a few goes at this, just experimenting with the z-remesher, and I don't really get it to a place where I would call it animation friendly necessarily, but you know, for a production. But or for a hero asset. But if it's a background character, or if you're just doing a still render, this is perfectly fine. And also for your delivery, if you're happy with the result the z-remesher is giving you, then I'm not very strict on that technical side. But if you wanted to be really particular about it, you would export the Dynamesh as an OBJ to Maya, just as I showed you earlier. And you would use the make the object live in Maya and use the quad draw tool. And just start painting polys manually. So the way you'd start out then is that you start with a good approach is just to start with the innermost edge loop around the eyes, and then the innermost edge loop around the mouth, and then you build it out gradually. So you'll just keep building out edge loops or rings or face paths, right? So rings of faces that radiate out from the eyes and out from the mouth. And it's going to be a big job, but a big tip is to not start out with too many vertices when you're painting. Just start with a fewer vertices. Even if you think that you might want to have a higher poly count in the end, as you're retopologizing, it's really helpful not to have too dense of a mesh. But here we go. This is the first result here I'm getting. Just observing this, and it looks a bit messy around the mouth. So I'm just having another go at it. So I think this is definitely a process where there's a lot of experimentation. And it's going to vary a lot depending on your character, what type of mesh it is. And of course this process is not limited to characters. So especially if it's especially if it's static objects, the z-remesher is great, because if you don't need animation-friendly topology anyways, it's just a really great and extremely quick way of generating topology just from a Dynamesh sculpt. So I'm making the draw size a bit smaller so I can be more accurate with the curve. So here again, I'm just experimenting, drawing some curves, and I'm just going to check the result from the z-remesher. But I'm trying to establish a little bit more, trying to define the shapes a little bit more, since it was a little messy around the mouth. So there, I'm just running it at a target poly count of 5, which means the final mesh is going to be approximately 5,000 polys, which is fairly low. There's a slight improvement there in the mouth, but it's still a bit messy. Also not too crazy about the radial topology at the top of the eyes there. So here I have one more go at this, and I believe this will be the final one. So I'm just showing you the whole process here. Because I think it's worthwhile. This is definitely, like I said, is part of the process. Very rarely are you going to get it the way you want right away. Actually, that was the one I ended up with. Okay, so I just said, okay, I'm happy with that. Obviously, looking back at it now, I still see that it's not a great topology, but for a still render, and this topology is definitely it's pretty good. It's just not perfect, I would say, for a hero asset. If this were to be part of an animation film or some larger project and it's going to be close to the camera, I could have used the z-remesher and then I would have perfected it further using the quad draw tool in Maya. Just making some quick UVs for it in the z-remesher. Checking with morph UV. And there we go. Just store that new OBJ that has UVs. And the first thing I'm going to do here is just to show a character, this character rendered with a normal map. So here we go. We have tangent space, adaptive, smooth normals, and I'm flipping the green channel and going to the highest subdivision level. Just pressing D to get to the highest subdivision level, and then just exporting this normal map. And ZBrush is going to bake that out very quickly. And it's set to 4K. It's going to be a 4K map. Just checking to see if the normal map looks fine. Looks okay. So I'm going to do a comparison here between just this OBJ that's just straight out from the Dynamesh, which is obviously going to look really good. But then I want to see how close can I get the normal map version to, what would that look like side by side rendered in Arnold. So here we go. I just attached a normal map. Remember to change the color space to raw on the file node. And then this is not the one that's going to have a normal map, but I need to export. I guess I already exported it. But here we go. Batty 03 with UVs. And I'm just making a note. This is the one with single, like a single region UV. It's not the UDIM version. So after this, I will show how to set up multiple UDIMs and also render out 32-bit displacement maps from ZBrush and rendering it in Arnold. But first off, Dynamesh, which is granted, fairly simple. So here, soften edge, just to get that the edge normals, just average those out so we get a smoother look. Again, just going and double checking everything is fine. Click number 6 just to see what that looks like. So currently that's just attached to a blend shader, but I really want to try to render it with Arnold to really see what it's going to look like. So one thing though, I think I kind of forgot when I was recording this, but in the file node, I believe is where it was, there's an Arnold tab, and you can go in there and you can click flip G to actually flip the green channel on the fly. So if the normal map doesn't look right, a good tip is to flip the green channel. Sometimes you have to flip some of the channels. So I talked a lot about that in the lab session, so if you want to look at that recording, we do this. I do figure that out sort of in the course of that lab session. So here I'm adding a sky dome light. I'm just going to turn that down way low just to get some general fill light, and then for this render I'm just using a directional light. Creating an AI standard. Assigning that to the objects. And then graphing input and output connections on both the blend and the AI standard at once. And then I'm using the same normal map here. I just broke the connection to the blend and moved it down and attached it to the AI standard instead, into the normal camera attribute of the AI standard. And then I'm rendering using the render cam that I set up. So it's a good habit to go in and make a separate camera, just set up the way you want. So here we go, side-by-side comparison of the two. Just going to go in and lower the diffuse a little bit and turn up so we have a little bit more of a specular highlight. That's going to make all those details pop out a little bit more. If it's a very, very diffuse surface or diffuse material, it's going to be a little hard to see. So I'm also increasing the contrast a little by making the directional light a little brighter. So we have a little bit more clearly defined. So there you see the one on the right being just with a simple normal map applied to a fairly low resolution object, and the one on the left is the full Dynamesh resolution. So you can see with this, depending on, of course, the distance you are to the object, you can get away with a normal map in a lot of cases. So normal maps are really great for just bending light around the surface, and it really mimics really well surface details, like tertiary details, which in this case, a lot of what we're seeing is just small surface detail. But of course, the normal map is not really altering the contours at all. So if you have any large changes that you really want to see displaced, you have to use a displacement map. But normal maps can be really powerful, and also for rendering, also for VFX, but of course they're a lifesaver for games because they're just computationally really, really quick. Okay, so pretty happy with the normal map. So I'm just saving out this ZBrush file, and now making another one for UDIMs. I'm just going to go ahead and show the UDIM approach. So to make the UV layout, I'm going to use Hedis UV layout for this. Saving out a version of that OBJ that I'm going to turn into. Make sure it has UVs for a UDIM approach. So for this, I'm just setting up a little bit nicer render. So I really want some sort of interaction. So I'm making a plane. And that's just because I want to have some contact shadows. I want to see those busts sort of in a studio setting. So I'm making a backdrop here, just using a standard plane. Just extruding the edge up here as I get a little bend, pressing 3 to subdivide that. And let's see, I'm going to end up assigning another AI material. So AI standard. AI floor material. Just renaming things so I don't get confused. So later on I'll be attaching an HDR file to the dome light. And what's nice about having the actual geometry there, also for the the studio backdrop, is that it's going to receive the same light information as the objects. It just seems like they're part of the same world. But here I'm actually going into a relationship editor called Light Editor, and here I can make it so that the plane is not receiving light from the key light, no, from the directional lights. So I have two directional lights here, but I'm just making it so that the plane is not actually receiving light from those lights at all. So there we go. So the only thing I wanted to achieve, you see at the bottom there, we can see some really nice contact shadows, and it just feels like they belong. They're more firmly placed within a setting, and not just floating in midair. So I'm keeping the renders pretty small resolution for now. In the very end with the 32-bit EXR render, I am Yeah, I'm making a 4K render in the end because you really need some definition there to actually, pick up the detail. But when you're just look deving and you're working, I really don't want to be making 4K renders all the time. That's going to slow down the process by a whole lot. So it's a good habit to be rendering at a low resolution for the look dev part. So I'm just opening the OBJ in Headers, UV Layout Pro. And I'm just going to start chopping it up into pieces. So here, in this workflow, you don't have to worry about seams at all because we're not using Photoshop to texture. All the details are baked from ZBrush, which recognizes UDIMs and does a beautiful job with baking the maps. So the seams really won't be an issue. But if you can, you don't have to place a seam, in the middle of the face. But technically, you should be able to get away with it. But typically, then we want to keep the middle of the face obviously as one UV shell, but don't be afraid to go in there and cut wherever you need it. So there, I just remembered that I need to activate symmetry before I start cutting here. So just going to edit, find symmetry, then establishing the center line, and then I start cutting. So just pressing C to cut and enter. So I cut that whole face mask off, and I think I'm ending up cutting off the airs here. I only have to do that on the one side, which is really nice when you activate the symmetry. And I can see that this piece probably won't flatten out very nicely, so I need to make some more cuts. And again, don't have to spend too much time thinking about it, just cut it open. So there we go. See if I can get a fairly distortion-free face, but here we go. For this example, I'm just making a cut straight across the face there. Like I said, it's probably not a good idea to do if you can avoid it, but it's just to get minimal distortion, because that becomes the main issue then, right? So if you don't have to worry too much about the seams at all, now it just becomes about having minimal distortion. So if I see some distortion there, I just make cuts. And that's really it. Just keep cutting away, making pieces. And I'm making sure not to scale any of these pieces individually. I do believe I end up doing that at the very end. So you do have that liberty if you want to allow some more texture space in some areas and a little bit less for other areas. You can do that. It's not going to look, it's just going to affect the texel density, but it's not going to be noticeable. You just have to, there needs to be a reason for it. Like what I'm doing here is that I see that there are some faces that are underneath the bust. And I do keep them there, but I just go in and make sure to scale those shells down quite a lot. Just distributing all the UVs right away into separate UDIMs. But I'll be working a lot more with the UVs, or a little bit in Maya for the final placement. And also scaling them up a little bit and so forth. In the UV texture editor. So here we go, just have a few pieces. So I'm slicing this up a little more. Just dropping all those. Yeah, so to get those symmetrically applied, I just hit S for symmetry. So I just unflatten one piece and then hit S And since the symmetry is enabled, it's going to copy that flattening operation to the other shell, or to the other half of the shell. So there we go. Currently 8 UDIMs. I think I end up using 7 because I'm able to 7 or 6, I don't remember, because I'm able to save some space by scaling down those faces that are underneath. But I'm not too concerned with it, as long as I can see that I'm sort of maximizing the usage of. So here, just exporting that OBJ. Now, here I'm trying to figure out like, so which one of these are actually underneath. Figuring that out. Just selecting the UV shells and observing the mesh. Just moving those to the side. So there we see I have the whole underside there isolated. Yeah, so here I'm actually just thinking about it for a second because I need to extend the grid line. So I want to have I can type in 10 units here, and then grid lines every 1 unit. I'm going to get something like this. It's going to show me just 1 grid per UDIM. Here I'm just scaling everything at the same time, making sure still just to keep a uniform texel density. And just observing the middle one. And here I'm using the middle mouse button. So I'm still in that move tool, but I can use middle mouse button. And then I'm just deselecting the ones I'm placing, and I keep moving the rest using middle mouse button. See if I can place those together. Yep, seems like it. Control deselect, just moving that into place. Alright, see, I'm just gonna cut that in half. Yep, so I don't mind too much. Again, cutting things up, it's really fine. Thinking about maybe I can fit even more things in there, but I'm thinking ahead a little bit. I'm thinking maybe I'll just place the bottom pieces in there. And again, the main concern being not to have overlapping UVs. If I do, the baking could fail, and also that none of them are actually outside their patch area. So there I have the bottom pieces, and I'm just scaling them down and finding a place for them. And that's going to save me a whole entire UDIM. So it's worthwhile doing that. And they're still fairly high res. You know? It's not like if I were to observe the object underneath, you know, it would still probably hold up. It's just going to be a little bit lower resolution than the rest, which is fine in this case. So just saving that scene underscore UDIMs, so I know this is the version that has the UDIMs, and I'm exporting this OBJ again. I'm just overwriting that previous one. This has the final UDIM patches. And back in ZBrush, I'm just going to use Subtool Master multi-append. That's going to go straight away into the file browser, and it will just add another subtool there. So there I have the retopologized multi-UDIM mesh, and I subdivide it up sufficiently. Then do the project all. So you need to have the bottom one selected, have the Dynamesh with all the detail on the top. Both need to be visible. Then you hit project all. And I'm doing a displacement. Adaptive 32-bit EXR. Mid-range is turned to 0. That's really all you need to care about. And then in the file names, just making sure Well, it's just going a little fast, isn't it? I'm just going to go back there a little bit. And the file names, let's see here. So projecting all the details. Then I'll go C plugin, multi-map exporter. Doing a displacement map. So there's the adaptive 32-bit EXR, mid-range is turned to 0. And then this is the thing, you just make sure that under displacement map naming, this is okay, but this needs to be followed by a dot. So you go in here and you type this, make sure this is followed by a dot, and then you change the UV tile ID format to UDIM. That's really all you need to do in terms of the naming. And then create all maps. And I was doing other things also on my computer when this was exporting, so it took a really long time. But I think if you just leave your computer alone and only have ZBrush open, you shouldn't be touching a whole lot of other things on the computer when ZBrush is computing this. So just leave it be, and then the process will be pretty forgiving. So let me just go forward here a little bit. Yeah, so all those are exported. I think it took like 45 minutes or something. But I think that was because I was doing other things. But it was 6 4K 32-bit EXR displacement maps. So there's quite a lot of data also to process. But here we go, going into the Hypershade. I'm just going to show the setup for this. So that was the previous normal map render, but now it's making a new AI standard. Just deleting all the other unused nodes. And graphing that so it appears in the work area. So I'm going to look for a file node, turn off filter type. I'm going to go and find that first EXR and change the color space to raw. And then for the UDIM naming convention, I need to make sure this is an absolute path. And you can see it's not currently. It just says source images, so that's a relative path. But I need to have the absolute path. That means including the directory where the Maya project is stored. So here I can go and see it's in the D drive. I just copy that and literally paste it in there. So make sure it reads the entire path. And I'm going to replace that number in bracket, UDIM in lowercase, and end bracket, and hit enter, and that's it. And that should make Arnold read all those UDIMs automatically when it starts to render. And then I'm making a displacement node, and I'm going to take the out color R because the information is stored in the red channel. I'm adding that to the displacement value, adding the AI standard to the surface shader. So you can see both the AI standard, it also had its own shading group, but I just deleted that. And I'm using one shading group. So as you can see, the displacement shader goes into the displacement shader. The bottom attribute has all the displacement data, and then the surface shader is the AI standard. And also I need to go into the object itself in the Arnold tab, select Catmull Clark. And here I'm just going into ZBrush, making sure to see how many divisions I have. So you see it's set to 4. Because it's fairly low. I only have like under 700,000 polys. So I'm setting this to 4. It means it's going to subdivide 4 times. And I changed it also to edge length. You can also set it to automatic, but edge length, I think it's a little quicker for this. And it's a bit more accurate. I mean, it's never going to subdivide over the required amount for this. Because I know what the maximum amount necessary is, because I have that defined in ZBrush. So if I subdivide this 4 times in Arnold using this displacement map, it should look very, very similar to the ZBrush version. So here I'm just kicking off a render, and there we go. So that's the mesh, and then we see there's no apparent error in terms of glitching or something between the patches. So it's reading all those 6 EXR displacement maps. I'm just going to try to render a higher resolution. So one thing to take note of also is that Arnold is actually converting all of those EXR maps into something called TX files, texture files. That's Arnold's own little format, and it makes it able to render much quicker displacement maps. I mean, it just handles it very beautifully. And the beauty of these 32-bit EXR maps is that you don't have to worry about the scale. It should work. You know, if you follow this procedure, if your mesh is technically accurate, and the baking went well, then the rendering should be fine. So there we go. There we have a full HD render with the displacement maps. So it's looking pretty good. And here I just want to have a sphere. Oh, okay, so I'm adding eyeballs again. Just makes it maybe a little bit nicer to look at. So so the TX conversion is no big deal. It just means it's converting all those EXRs automatically into TX files. And if you take a look in the file browser where your EXRs were stored, you'll see new files named TX files. I'm actually importing that into ZBrush for the placement of the eyeball. That might seem unnecessary, but I need the high resolution version. As you see, to open that file again. I need the high resolution version of the mesh in order to really see where the eyeball should be placed exactly. And it's going to place it, it's going to look exactly the same in the Arnold render, but it's going to be difficult to place the eyeball in Maya using the very low resolution mesh, because it wouldn't really tell me where it needs to be placed. I'm just hinting at some detail there. I'm not gonna. So you could spend time building an eye. That would be a nice little project in itself. But for this, just a quick clay render of this concept sculpt. So then I'm happy with the placement. I'm just going to delete the subdivision levels, delete lower levels, and just export that OBJ. Eyeballs. There we go. And just to have some more interest in there. And also adding a material for them. So it's nice to, like I said, set up render cam, because I always make sure to render from that camera, and then I can just keep working, observing the scene through the perspective camera and not the render cam, because the render cam is just kept static, and it's just easier to keep look deving and keep making changes and always observing the same angle. Well, you can change it, but you know what I mean. When you're making small tweaks, you want to sort of have a nice before and after look. You will click right here to keep the image, and then there's a scroll function at the bottom, and you can scroll between the current render and the previously stored render image. So, so here I'm just playing around with that little material for the eyeballs. Just want to have a little bit more reflection happening in them. And currently, it's hard to make reflection convincing in the scene because the only thing that's actually reflecting is the light. But I also want some sort of a environment, right? So that's really one of the reasons to use an HDR for the light, the probe light. If you attach an HDR image, it's also going to provide some sort of setting to be reflected. And it makes a big difference in terms of the believability. So the HDR I end up using, it's on the server. You can go and grab it. You'll see the path. And it's just an HDR of a sort of a studio setting. But so I'm not really going in and doing more with the reflection here before I add an HDR, because it's going to make it's actually going to make a pretty big difference in terms of having an environment. So here we go. I'm going into teaching, jewels, resources, HDRI. And in here you'll find some HDR images. And these are actually from Substance, so Substance Painter. So just having a look at them in Photoshop, seeing which one of them I'm going to try using. So I end up using this one, which is, like I said, it's just like a studio setting, but it just creates some more interest rather than having just a pitch black Maya scene with a few lights in there. This will provide a much more convincing overall light setting. So I'm just attaching that to the color of the dome light. So, and touching that file node, again turning off the filter type. So you can see it's also an EXR 32-bit image. Changing this to RAW. And I'm keeping that image, and I just want to compare, just saving the scene before I start rendering so I can easily go back if something was wrong. Just saving this version _HDR, so I know this is the iteration where I started working with the HDR. So, just need to do a render and start dialing this in. So right now, we don't have a lot of really reflective surfaces. It's hard to see. So you'll see me adding a chrome ball here, just to really see what's going on. But you can see a really nice gradient currently happening also with the background. It just feels like a little bit more believable kind of a setting. It's really nice fall off shadows on the ground there that the bust is casting. Yeah, just playing around with the intensities. I'm going to increase that for the HDR, for the intensity of the dome light, and then I think. Oh yeah, so here I'm playing around with. There's also another way to add HDRs and environments in Arnold, but I don't end up using this. I'm just kind of remembering what this was all about. But the way you really want to do this, the preferred method is doing what I just showed you. So using the dome light, just attaching it to the color. In Arnold, that's a really great way to add image-based lighting. But here, just to really show the effect of the environment, I'm adding a sphere. And I'm going to make a chrome material for this. So just a really perfect reflective material, which is actually computationally very simple to do. It renders really quick. What's a little bit hard, takes longer to render is more rough type of reflections. But really specular, shiny, perfect reflections are actually pretty simple, because the light is just reflecting very predictably. And to do that, you just turn the color to pitch black, and you turn the weight and color of the specular way up. Oh, that was pretty quick. Let me go back. So this is also kind of outside the scope of what we have time to cover in this class, but let's see. Let me go back here and where? Okay, I'm just gonna let this run until I come back to that point. But in terms of physically based rendering, there's two main methods. One is for well, they're both pretty much they will give you the same results. Let's see here. But yeah, so I'm just gonna say now that for Arnold, what you want to do might differ a little bit from something like if you're making maps for Unreal, which has a different approach. But they're both very similar. It just has to do with the way the maps need to be authored. But yeah, so anyway, so that, like I said, that's a scope, that's a bit beyond the scope of this class. But here in the Arnold material, so to make a perfectly reflective material, what I want to do is turn down diffuse to pitch black, and then I turn the specular value way up in the color and also the weight, set that to 1, and I turn the roughness value to 0. And yep, so you'll see me doing that. So there we go. When I render that, it's going to show all the reflections in that sphere. So I'm just rendering that region, so I don't have to re-render the whole image, just to show the effect of having that environment. So there we can see the environment reflecting inside of that sphere. And I figure I can dial these lights just way down, and I rather let the HDR environment provide most of the lighting. Just want to see what that looks like. Turning down the resolution a little bit, just to do this is just a look-dev render, so there we go. I'm just going to be dialing this in a little bit. It looks a little bit pixelated, but that's just a light that actually needs some more samples. So on the dome light, you can see right there, you have some samples. So using up the samples, but here I'm playing around with the material for the eyes. Just doing some look-dev rendering. Also, you can see that little icon in the material attribute editor. It will update when you make those changes. It's kind of nice. There, we're starting to see more of some reflections in there. Here I'm playing around with the material for the skin. Well, it's not actually skin in this case, just wanted to make it look like. I wanted to have some reflection, but I want the reflections to be fairly rough for the actual clay or whatever. So I also up the samples in the dome light, set it to 3, so now we get a little bit cleaner result. You can see you have some reflections in there for the eye, the material used for the eyes, but the reflections for the skin, it's just more subtle, more rough. And I'm still dialing in that. Changing a little bit now the render cam. Just want to go in a slightly different angle. And if you wanted to experiment a little bit with changing the color of the background or something, but I just want to keep this fairly subtle monochrome for now, and then I end up adding just a little bit of filter on it afterwards. Yep, so here I'm typing in 3840 times 2160, 4K custom resolution. Just want a higher rendering once again with the render cam. So I kind of like that new angle. And you'll see that the increased resolution actually adds a little bit. It's able to pick up more of that detail. And this is also still a fairly rough model. You know, I could have gone in there in the tertiary stage and taken this further in terms of small wrinkle patterns and pores. And it's not taken to that final polished level. It's a fairly rough tertiary stage on this bust. But all those details would have been able to, you would have been able to capture that using this approach. And also then it could have been helpful if you had a lot of smaller details, also to enable the auto bump feature, which is under, if you click the mesh and under the Arnold tab, where you do all the settings for the displacement map, where you set it to Catmull Clark and how many divisions you want. You also have the auto bump feature. It's going to treat those final tertiary details, the really, really fine ones, and actually apply those as a normal map. No, as a bump map on render time. Which is just very efficient. So there we go, it starts looking more like the ZBrush sculpt, but now in a bit more believable and physically plausible render. So remember what we did in the beginning where we made sure the scale was correct. Now that's paying off because all the light is actually behaving a bit more naturally to the size of this object. Alright, gradually getting there. Yep, so rendering is not the most fun thing in the world, but it's quite fun to see things finally come together. So, you know, still quite a bit of technical things to do to arrive at this stage, but we can see that things are working beautifully. I remember there's even like some UV seams just straight across that his face, and we wouldn't be able to notice. So it's great that, you know, it's come to this point where, yeah, there's a lot of things to set up, but the tools we've been using are pretty forgiving. You know, it's a pretty straightforward process. Yeah, so while I'm waiting for that render, I'm just finding some, or actually just making a point here is that you can, if you want to in the final comp, add some dust particles or make it look slightly less like a CG render. If you just want to try experimenting with that in the final Photoshop composition, but you know, I would keep things very, very subtle, because too much might just take away from. This is really just showing off that concept sculpt. It's not really a finished conceptual artwork, but you can still add a little bit, you know, make some gradients, dust particles, things like that, or some simple color correction, even though this is just pretty much a monochrome. You know, there's no colors in my my render, but I can still add some filters like a cooling filter, or make it warmer colors depending. So yeah, so I think I'm just gonna go forward here a little bit. So I think that's pretty much it. You know, I'm just saving this out as a 4K image. So there's the final render. I go save image, and that's how I'm just going to be able to store that straight out as a PSD. Just straight out from my stored out in an images directory. Render 4K, and yeah. So that's really it for the technical parts. And then you have a 4K Photoshop. Oh, important point. So you see that this image is a bit darker than the render. So that has to do with linear workflow and, you know, adding LUTs and all of that. We don't, again, outside really the scope of this class, but suffice it to say that we need to add a gamma here of 2.2. So if it looks too dark, you can go in Photoshop, add a 2.2, and if you compare that to the render, you should see that that corresponds nicely. So, but that's an important point, and it's a very quick fix. So Control L, you can actually just add that in Photoshop. Make sure your renders are not appearing very dark when you submit them. Yeah, just experiment a little bit with some particles. I'm not sure really if that's really working out too great. But I also end up adding some cooling filters and yeah, don't worry. It seems like I'm going crazy, but I'm not. Making it pretty subtle in the end. But here you can add some adjustment layers. So adjustment layer, like photo filter. Make like a cooling filter. You know, still pretty subtle, but it can make it interesting. You know, really just showing that yes, you can make some final tweaks if you wanted to. So, but I think that does it. And that's the final one.